Alright, lesson 8.8 is factoring polynomials completely. And so far you've used the distributive property to factor out a greatest common monomial from a polynomial, but sometimes, as is this case right here, you can factor out a greatest common binomial. For example, we have the expression 2x times the quantity x plus 4 minus 3 times the quantity x plus 4. So these products right here both have a factor of x plus 4. So I'll factor it out. And remember, when you factor it out, before we would factor out a greatest common factor and then we put parentheses in to see what we got. So if I factor out the x plus 4, from my first portion of the expression I'm left with a 2x, and for my second portion I'm left with a minus 3. So this is factored out completely. Now if I look here, you have to be careful. This is y minus 2, this is 2 minus y. These are not the same thing. But I can manipulate this and rewrite it as minus 5 times y minus 2. Because if I were to do that, that would end up giving me 5 times 2 is 10. Well, negative 5 times negative 2 is 10. 5 times negative y is negative 5y. Negative 5 times y is negative 5y. So I've manipulated it so that my binomial factors are the same. So I will factor out a y minus 2, and from the first expression I'm left with 3y squared, and from the second one I'm left with a minus 5. And this cannot be factored out any further. So let's keep going. In some cases you're going to have to factor by grouping. What we're going to do is we're going to group the highest two powers of x or y or z or whatever it happens to be in the terms together, and then the smallest two. It says factor common monomial from pairs of terms, then look for the common binomial, which is what we just did. So here I'm going to group these two, and I'll group these two. When I group these two terms, they have a common monomial factor of x squared. So when I factor it out, here I'm left with an x, here I'm left with plus 3. Well, if I look at these two terms, they have a common monomial factor of 5. When I factor out a 5 from the first term, I get an x, and from the second term, I get a 3. So now it takes me back to what I did on the previous page. These both have an x plus 3. So I factor out the x plus 3, and from the first one, I'm left with x squared. The second one, I'm left with plus 5. So it takes more steps. I'll do the same thing here. For the first two, I'm left, I have a y, and I end up with y plus 1. And in the second two, they have an x in common. And when I factor out the x, I'm left with a y plus 1. Now these each have a binomial common factor of y plus 1. When I factor it out here, I get a y. When I factor it out in the other one, I get an x. So y plus 1 times y plus x, or you could have y plus 1 times x plus y. It doesn't matter. Let's try this one. Again, I'm grouping them. If they are not grouped from highest to lowest degree, you need to do that first. All of these have them, but just be cautious. So here they have an x squared. When I factor it out, I get x plus 5. If you have a negative leading coefficient, make sure you factor it out. So with 8 and 40, I can factor out the 8, but I'm going to do minus 8, which gives me an x, and then plus 5 again, because negative 8 times 5 is the negative 40. So my binomial factor is x plus 5. And when I factor it out in the first one, I get an x squared. The second part, I get minus 8. So factoring by grouping. Okay, there's a lot of reading on here. It says you've seen that you can factor x squared minus 1 as x plus 1 x minus 1. This polynomial is factorable. Notice that the polynomial x squared plus 1 cannot be written as the product of polynomials with integer coefficients. So that polynomial is not factorable. There's nothing we can do to an x squared plus 1 to simplify it any further. A factorable polynomial with integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So once you get it down so that none of the parts can be factored any further, you're done. You have factored it completely. These are the guidelines. The first thing you want to do, and I keep saying this, is factor out the greatest common monomial factor. The next thing you do is you look for the difference of two squares or a perfect square trinomial. You look to see, is it one of those special products? If it's not a special product, then you just simply factor the polynomial by the guess and check method. And then another thing you want to look for is grouping. So you have to see, can I group? So here in this particular one, let's go ahead and try and factor it. There are no common factors. It's not the difference of two squares. To be a perfect square trinomial, the first one is a perfect square, n, but the last one is a negative 1, so there's nothing I can, if I square root 1 I get a 1, but I can't square root a negative 1. I'd have to go n and n. The only factors of 1 are 1 and 1. But the only way to get a positive 2 out of this is to put a positive 1 and a positive 1. But 1 times 1 doesn't give me negative 1. So this is not factorable. I can't take it any further. Okay, if I look at this next one, first thing I want to do is factor out a common monomial factor, and that is going to be a 4 and an x. So then I will go through and factor. This gives me an x squared minus 11x plus 96 divided by 4 is 24. And now I need to go ahead and factor the x squared minus 11x plus 24. I'm going to get an x and an x. Since my leading coefficient here is 1, I want factors of 24 that will give me an 11. This is positives, and this middle term is negative, so I know they both have to be negative. And it's going to be an 8 and a 3. Negative 8 times negative 3 is positive 24. Negative 8 plus negative 3 is negative 11. So I'm good. On this one here, I have only two terms. When I only have two terms, I always think about a squared minus b squared, the difference of two squares. So I'm going to factor out the 2, and I'm going to factor out an h squared. When I do that, I get a 25h squared minus 1. This is in the correct form. So the square root of 25h squared is 5h. The square root of 1 is 1. And I go plus and then 5h minus. And if you were to FOIL this, you would end up getting 25h squared minus 1. So these are factoring completely. Now we have to solve them. Remember, to solve them, nothing has changed. We still have to set it equal to 0. So for this first one, I'll go 3x cubed plus 18x squared. I'll add the 24x and set it to 0. Now I want to go ahead and factor out the greatest common monomial factor, which is a 3x. This ends up giving me x squared plus 6x plus 8 equals 0. This is not a perfect square trinomial because 8 is not a perfect square, so I keep going with my guess and check method. I have an x and an x. Factors of 8 that will give me a 6 are 4 and 2. This is factored completely because x plus 4, x plus 2, they're called linear factors because they don't have an exponent in them, as well as 3x. So I have to set 3x equals 0. I can't just eliminate this now because it does have the variable. And then I go x plus 4 equals 0 and x plus 2 equals 0. So the first one, x equals 0. If I subtract 4, x equals negative 4. If I subtract 2, x equals negative 2. So what that means is with this particular function, it's going to cross the x-axis 3 times. Once at 0, once at negative 4, and once at negative 2. So let's go ahead and try this one. I do have a common monomial factor. It is a w, so it doesn't have to be a coefficient. It can just be the variables. This gives me w squared minus 8w plus 16 equals 0. This is actually a perfect square trinomial. And I know that because the first term is a perfect square and so is the last term. The square root of 16 is 4. I separate this with the subtraction sign because it's a negative 8w. So now I set these factors to 0. So the first one is just w equals 0. Remember, this is one where you only need one factor since they're the same. And so w here would equal 4. On this one I can factor out an x. That gives me x squared minus 25 equals 0. This is the difference, sum and difference here. So the square root of x squared is x. The square root of 25 is 5. And it's plus and minus. So I end up with x equals 0. And I set each of these to 0. So I get x equals negative 5 and x equals positive 5. Here again I can factor out a c, so I get c squared minus 7c plus 12 equals 0. And it's not a perfect square trinomial, so I just have to factor the trinomial. I get a c and a c. This is positive and negative, so it's got to be negative, negative. Factors of 12 are 3 and 4. That would give me a negative 7 and a positive 12. So c equals 0. C equals 3. And c equals 4. And lastly, we have a terrarium in the shape of a rectangular prism. It has a volume of 4,680 cubic inches. Its length is more than 10 inches. The dimensions of the terrarium are shown. Find the length, width, and height of the terrarium. So, length, width, and height, I know that my volume is 4,608. That equals 36 minus W times W plus 4 times W. So this is very similar to the problem that you had on your quiz. I'm going to go ahead and multiply these. 4608 equals, when I do this, I'm going to go ahead and just use the box method real quick. I have a 36 minus W and a W plus 4. This gives me 36W, negative W squared. 36 times 4 is 144. And I get a negative W. My like terms are still on the diagonal, they're just in this direction now. So that gives me negative W squared, and then I end up with plus, it looks like 35W plus 144. Oops. I still have to distribute now the W. So when I do that, that gives me a negative W cubed plus 35W squared plus 144W. Now in order to solve this for the width, which is what I can find in the beginning, I have to set it equal to 0. So I have a negative W cubed plus 35W squared plus 144W minus 4608. This one I have 4 terms. Whenever you have 4 terms, you need to immediately think grouping. So I will group these two and I will group these two. When I group the first two, I'm going to factor out a negative W squared. And when I do that, that gives me a W plus 35. Nope, W minus 35, sorry. And for this next one, I'm going to see if each of them are divisible by 144. So 4608 divided by 144, it does equal a 32. So I'm going to factor out a 144, and that gives me W minus Alright, I went off camera for a while. I see that I made a mistake. If you caught that mistake earlier, then bravo. This should be a minus 4W in here, which makes this a 32W, so please overwrite these. And when I do that, this gives me a 32W squared, which makes ultimately this right here minus 32. So go ahead and fix that. I'll give you just, well, I mean, you can pause me, but you need to fix that so that we can actually move on with this. So now I see that I can factor out a W minus 32. And when I factor it out of the first part, I get a negative W squared. When I factor it out of the second part, I get a positive 144. It might be better for us to write it like this. So let's come over here. 0 equals w minus 32 times 144 minus w squared. The reason I want to write it like this is now I can see that it's the difference of two squares. So I've got w minus 32, and then the square root of 144 is 12. The square root of w is w, so plus w and minus w. I do need to set these equal to 0. So I have w minus 32 equals 0, and I end up with w plus 12 equals 0, and 12 minus w equals 0. So here w would equal 32, and here w would equal negative 12, and here w, I'd end up with a negative w equals negative 12, so w would equal positive 12. So it appears that two answers are going to work. When we put them in here, let's see what happens. So when I put it in, for w, 36 minus 32 would equal 4. But it says right here the length is more than 10 inches. So none of these can be less than 10. So I cannot use the 32. I'm going to have to use the 12. So when I use the 12, I end up with 36 minus 12 is 24 inches. The width is 12 inches. And the height is 12 plus 4, or 16 inches. So those are the dimensions. So even though I did get two positive answers, and I know I can't use a negative, I cannot use the width of 32 because then that would make the length less than 10. Alright, your assignment, if you want to get started, is actually worksheet 8.8. Yours would be called Practice B. I'm not going to print it off for you. You can just go right to your Chromebook and get on the website and look at it. It's under Student Resources, and it would be Practice B. And you can just pull it up because I'm expecting you to write down every problem and show the work anyways, because you'll see that there's not enough room on it to actually show your work or write your answers even on the worksheet.